All right, welcome. Today we're going to tackle two of the absolute biggest ideas in all of statistics, population and sample. Seriously, if you want to understand how we make sense of our world with data, getting this right is the essential first step.
I mean, just think about that for a second. How do election polls work? How does a company know if you'll like their new phone? They all face this exact problem. How in the world do you get reliable answers without talking to everybody? Well, that's the puzzle we're going to solve today.
Okay, so let's dive right in. You know, the most obvious way to figure out what an entire group is up to is, well, to just ask every single member of that group, right? This method actually has a name. It's called a census. And while it sounds perfect on paper, in reality, it's often a truly massive, sometimes impossible challenge. So check this out. What we're looking at here is a classic trade-off. On one hand, you've got a census. It aims for perfect accuracy by studying every single person or thing. But the cost, both in time and money, can be just astronomical. On the other hand, you have the sample survey. Here, we're only looking at a small slice, a part of the group, which makes it way more efficient and practical. This is exactly why it's the go-to method for pretty much every industry you can think of.
So if a full census is basically off the table most of the time, what's the elegant solution that statisticians came up with? Well, it all boils down to these two incredibly powerful connected ideas, the population and the sample.
Okay, first things first, let's get our definitions straight. The population, that's the big one. It's the entire collection of everything we want to know something about. And the key word there is entire. Not some of them, not most of them, but all of them. This is our ultimate target group.
And yeah, these examples really make it click, don't they? A population could be all the students at a college, or every single light bulb a factory makes in a week. It could even be all the customers who walk into a mall. The key is always all. The population is the complete set.
And then you've got the other side of the coin, the sample. If the population is the whole shebang, the sample is just a small, manageable piece that we actually study. It's a carefully chosen subset that we pull out from that much larger population.
And this is, hands down, the best way to make it all click. To know if your whole pot of soup, that's your population, is seasoned just right, you don't have to eat the whole thing, right? You just taste one spoonful, and that's your sample. It's a beautiful and simple idea.
So, why do we do this? You might be thinking, isn't sampling just settling for less? But actually, it's so much more than a shortcut. Using a sample has some incredibly powerful advantages that often make it a way better choice.
So let's break these down. First, the obvious ones. It saves a ton of time and money. It's also just more practical when you're dealing with huge groups of people. But get this, a really well-designed sample can actually give you more accurate results than a rushed or sloppy census. How wild is that? And finally, sometimes you just have no other choice.
And this last one is super interesting. It's a thing called destructive testing. Imagine you make light bulbs. You want to know how long they last on average. Well, to find out, you have to let them burn until they pop. If you tested your entire population, you'd have 0 bulbs left to sell. You have to use a sample.
So this all sounds amazing, right? A total game changer. But this brings up a really critical question. Can you just grab any old spoonful from the soup? Is any small group good enough to tell you about the whole thing?
And the answer to that is a big, definite no. The magic of sampling only works if the sample is chosen the right way. So what makes a sample a good sample? One that we can actually trust? Well, there are 4 crucial rules to follow. For a sample to be worth anything, it has to tick all 4 of these boxes. First, it has to be representative, meaning it looks like a mini version of your population. It needs an adequate size, because if it's too small, the results are just noise. It has to be randomly selected, giving every single person or item an equal shot of being picked. And finally, it absolutely must be free from bias. No cherry picking allowed. So how do you actually make sure your selection is random? You use a tool called the sampling frame. Just think of it as the master list of your entire population, like a school student directory or a city's voter registration list. You need that complete list to be able to draw a truly random and unbiased sample. Okay, let's bring all this home now. We've got the population, the whole group, and the sample, the little piece we actually look at. Now, let's lock in that powerful connection between the two.
And really, if you remember just one thing from all of this, let it be this right here. This is the whole point of the exercise. We study the sample, the part, so that we can make smart, intelligent guesses about the entire population, the whole. And here's where we get the official lingo, but it's super simple when you see it like this. Any number we calculate from our sample, like the average height of 40 students we measured, is called a statistic. And we use that statistic to estimate the true value for the entire population, say the average height of all 540 students. That true value is called a parameter. So we use a statistic to estimate a parameter. That's the name of the game.
Which brings us right to the fundamental question that drives the rest of statistics. We've tasted our spoonful, our sample, but how sure can we be that it tastes like the whole pot of soup? How do we know the part truly represents the whole? Answering that? Well, that's the next step on the journey.